Hi everyone. Thanks a lot for showing up in a sunny Sunday afternoon. I live in Amsterdam, so it's such a miracle that I would try to give the talk from outside. So the idea is that I'm going to give this talk about this package for AI debuggers, in the sense that AI debuggers are supposed to use this package. So there are no AI debuggers ready yet. About me a bit, I work as an AI scientist at HK3 Lab, which is a startup in Trento, Rovereto, about machine learning. I studied in California, neuroscience, but it was mostly neuroscience of GPUs, doing deep learning my whole time. And I've been now for quite a long time in AI before it was a cool thing to do. And I've been recently in the middle of the academia, the academia and startup world, so ending up naturally inside Python and open source development. So the idea is that the last 6 months have been pretty surprising from the AI perspective, mostly due to OpenAI releasing ChatGPT and showing that basically a lot of things that in the community we thought were sci-fi conversations about 2035 are actually our current research project. I, like a lot of other people, got kind of stressed of not having access to the actual neural network and only being able to play with such a system through an pretty bad API. So there has been a huge effort from the open source community on trying to replicate and start building open source research programs to basically get code ChatGPT for everyone, or like GPT-like assistant for everybody in the world. Open Assistant has been one of the first of those projects, and the participation has been overwhelming. I was there from the beginning, met a bunch of friends, and basically what we understood is you need data, you need GPUs. For GPUs, you have to beg venture capitalists and governments, but for the data, there is a lot that can be done, especially because the more a person is specialized and understands something, the better quality data it can generate. And of course, it's not only like writing down data like 1975, but there are a lot of automatic synthetic methods to generate very specific data. So what Open Assistant, like in 6 months, actually 5, is a full-fledged app, is running with compute from Hugging Face, Stability, and Redmond AI. And thanks to also Facebook release of a base open source model, it is actually a kind of decent piece of software at the moment, and it has been no money has been put in and thousands of hours from the open source community into it. Now, how OpenBugger fits into it? It's a small project started in order to generate Python coding datasets for OpenBugger, and then I have some friends that are kind of too good at coding, criticized the initial approach, using regular expression, made me study concrete syntax trees, and then 6 months later, I'm here. There is a kind of almost released package. There is a PyCon branch in the GitHub, which should be fully functioning, except that yesterday night, LibCST released their 1.0 version, so I'm not sure that if you pip install things are not going to explode. But basic idea is we want to create a huge data set on how to debug Python code. The idea is that it's much easier to find good code and bug it, and then look back at the original solution, instead of finding bad code that people don't really share. I mean, I produce a lot of it, so I could have just looked into my previous year's pushes to GitHub, probably. But it's very time-consuming to then debug it. And a lot of time to debug code, you have to execute it. And when you start using code written from others, going through execution is a pretty bad idea. So what we do is we use static analysis, and in this case, concrete syntax tree parsing to develop bugs as syntax tree operations. So I might go too deep because I got really passionate about different of these topics. So the spoiler of the talk is that language models really require a lot of data, very specific data. Good data are very expensive, and you kind of have to pay a lawyer price to have it produced. Like if you want a physicist to produce physics data, you need to pay a physicist consultant fee. If you want a Python developer, if you want top-tier consulting, Python consulting grade data, you need to pay 400 euros per hour a top-tier consultant in San Francisco and so on. So the idea is, hopefully, I can persuade you that OpenBugger generates quite good data for very cheap. So just to start, what are language models? And I'm here trying to be very, 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 very basic, not to spend the next 6 months discussing about it. It's a kind of very simple idea that was born right at the beginning of information theory. And it was an idea that was actually very related to digital communication and phone. And it was a tentative, actually, an early tentative of information theorists to compress data before communication. And then turns out Fourier transform is much better and so on. But the idea is that you are defining language as a sequence of tokens. A token could be a letter or a phoneme or a full word. And you only care about the sequence of letters or tokens in terms of their autoregressive ability. That is, the possibility of predicting xt plus 1 from the x that were coming before. In the case of language, let's say the tokens are, assuming the tokens are word, typically there are smaller components. Like if I say the sentence, the cat is on the, if people were born in Italy, we had the cat is on the table as example for every single English class of our life. So it's very natural to autocomplete in that direction. And that's kind of how the model does, only that instead of seeing our very subjective sequence of tokens that each of us experience through life, this is trained over the whole internet, or all of the internet that you can scrape without getting sued after you train on it. And what is the problem of these language models? These language models are literally tables where you have one side that is all the possible permutation of sequences up to that length, and on the other side you have all the possible tokens. So you can think that if you have only 2 tokens, you have, 4 possible sequences. But as soon as you have 3 and so on, you start having a huge amount of combinations. And these combinations are very conflictual with machine learning approaches. That is, the longer the context, so the longer the sentence, the more sparse the data are going to be. And the more data you're going to need to actually get a good estimate. So if you want to learn probabilistic models of 2 letters, it's going to be exponentially less data needed than 3 letters, 4 letters, and so on. And this was basically what killed this approach and made it a small subsection of an MIT department for 40 years, till we moved into neural networks and large language model. So the idea here is that even if the space is huge, actually kind of infinite from a human uncountable from a human perspective, like there are more possible combination of 8,000 tokens than there are atoms on the planet. But turns out that both humans and large language model are able to estimate the manifold of plausible token sequences that are still language in a very efficient way. So why these large language models are working now? They're working, we have this sort of ability to train this sort of function approximators since the early 90s, but it was very inefficient and the way that older models were trained was sequentially, like as if it was a for loop. And because it was a for loop, it was very, very difficult to parallelize. And because it was very difficult to parallelize, it was very inefficient to scale as a computation. 2017, Basvani, a senior at my PhD, during internship at Google, they developed Transformer, most cited paper that is going to be probably of the century very soon. And basically, they have an architecture that we had for 20 years that now can scale to 1 trillion of tokens. And indeed, that is what happened. So what did OpenAI did? Why did OpenAI, even if it was a Google invention, why is ChatGPT a model from OpenAI? because they really believed in that result. Because they were a company whose fundamental was building a very efficient cluster to train big models. And once they found that architecture, it was the biggest breakthrough possible from there. Because all of their compute could be allocated to training. Google has a very complicated budget for their computing and so on. OpenAI had $500 million from Microsoft to only spend in parallelizing transformers. On the other side, they had a very big experience on reinforcement learning from the Dota video game playing agent that maybe somebody remembers, and from a lot of stuff on robotics that are kind of disappeared, but they had a very dexterous, skilled robot. And they were expert, they had state-of-the-art code, and they combined the two things. And ChatGPT was out. This is the famous slide describing the pipeline that they have on their blog post, which kind of separates in 3 steps the creation of a chatbot assistant. The first step is large language model pre-training, which is kind of the most expensive and fundamental step. And this was the breakthrough enabled by transformers. And you literally need to take billions of sequences, actually hundreds of billions of sequences, ending up being at least a trillion and a half of tokens seems to be the correct number at the moment. And here is where we think that the model actually learns things. So most of the knowledge is learned in this step. And here knowledge means mapping from sequences to sequences, that sometimes in language, mapping from a sequence to a sequence is just a simple continuation, but other types could be a very complicated operator. You could be saying input, apply mathematical operator, output. Now this operation is a very complicated operation. But if there are enough examples, this model are learning them. Then there is a second part that is actually what OpenBugger is hopefully contributing into, which is creating instruction tuning data set. So it's not only plain sequences of text, but this is your command, this is your input, this is the output that you're supposed to be done. And this is like the very expensive to produce part, because if you want to have very good demonstration, you need to pay people that are very good at that. And that is what OpenAI did in comparison with cheaper work, in synergy with cheaper work that they got from Scale.ai. There were a bunch of scandals of remote African workers labeling for OpenAI. And basically, they used the workers to give a feedback to the model and then train it with reinforcement learning that, as I was saying, they developed a lot of infrastructure for Dota. They use it to finally fine-tune the model. The first part gives the model knowledge. The second part gives the model the ability to follow instruction. The third part gives the model that human feeling during the conversation. Most of the open source models do not have the third step. So again, OpenBugger is coming in the middle, in the second step, and the idea is that we use Python syntax tree mutation to generate high-quality debugging instruction. And that's where we go. Going back a bit to the first part, and I kind of want to give an update of what happened over the last 6 months in the language model department over here. So the idea is that there was the animal farm to the rescue. Facebook released the Llama model, which is a GPT-style pre-trained model. The model was trained on public data, but the data were not released. So the weights were public, but they required a form to be accessible. But then in 2 days, somebody committed a torrent link to the, to the repo, and the commit is still there. I think it's going to be one of the best memes of this phase of AI. And yeah, so basically now it's based Llama for everybody. And right after that, Stanford did another kind of epic thing from my perspective, where they just trained Llama on ChatGPT outputs, ignoring that like last big line of the TOS from OpenAI saying that you cannot do it. And turns out that OpenAI did not sue Stanford, so we all can do it now. Month later, the same guys actually from Alpaca, released an open source replication of the dataset from Llama. And this opened up dozens of different companies producing alternative models. Okay, So the idea is that the base LLMs are getting sold mostly from competitor companies trying to enter the space, and they have no private. They cannot sell a competitor to ChatGPT, so they give it for free. And that's kind of nice for us. And so what about the instruction tuning part? The instruction tuning part, there are thousands of groups doing the same thing I'm doing and creating data about their specialty, basically. So back to OpenBugger. So the idea, again, just to repeat, given that I went through 6 months of super fast time in the meantime, we try to use good code to generate debugging instruction instead of bugged code to generate it. The idea is that faster to implement a finite number of transformation that takes good code and move it into bugged space instead of the opposite and learning every possible mapping from bugged to not bugged. We use LibCST, so the bugs are introduced not as a string operation, so it's not a regular expression matching something and changing the string, but is a graphical operation over the tree. So there are some nodes we take the source code, represent it as a directly acyclic graph or as a hierarchical tree, and then substitute some of the nodes. Because not all the operations are actually possible in this way, so at the moment we only restrict to a single node substitution operation, such that we can always invert the bug. So we can chain bugs and invert them, and we are always able to go from good code to bugged code, back to good code again. So what are concrete syntax tree, and what is libcst, which is the package that allows us to run it? And basically, concrete syntax tree are a complication of abstract syntax trees that maintain all of the side information. So abstract syntax tree is a decomposition of a string representing source code that only contains nodes, operation, and the value of those operations. While concrete syntax tree, like in this way, concrete syntax tree also contains spaces, comments, and new lines, which means that there is a one-to-one mapping from concrete syntax tree to string, while there are multiple abstract syntax trees that could correspond to the same string of code. Because of this can be used for code generation, and that's what Black or other linting packages use. We are using libcst, which is the Instagram, so Facebook, open source library, and it is kind of the state of the art for code generation. So how do debugging works? The idea is that libcst has a structural match over a subset of the code. The code is modified by a node substitution. The new graph is inverted to generate some code, and this is the debugged code. The debugged code then can be parsed again. The nodes can be substituted again for debugging. These are the bugs that we currently have implemented. There are also some NumPy and the Pandas package-specific bugs. It's nothing fantastic. It's more an example, but they look kind of okay at the end. So this is like an example. So this is an infinite while. This is a bug that nobody here should be producing by themselves. But basically search for all the while nodes and substitute the target condition of the while nodes with a true. So the loop is going to go forever. And there's also is a bug that you cannot solve by running the code. So it was a bit to show off the power of static tools. So this is the example. This is the original condition. And that is what would happen after the bug application. This is the debugging stack trace that we automatically generate from inverting the bug. And this is kind of the big contribution that we have to data generation, is that we're able to generate these automatic, very precise and correct by definition debugging traces that then we will feed to GPT to create fake conversations about debugging code. This is another example. So this is a bit more complicated. So it's like, this is actually something that can happen. So in Python, one keeps going back and forth in between lists, sets, and dictionaries, and they all have a different concatenation method. And this is searching for your dictionary and putting an append instead of a concatenation, or going to sets and adding updates and things like that. So again, many more steps. There is a cycle of recursive structural matches, and then the code substitution. This is the example. We have a list, and we make it a dictionary. Now, This is what do we end up doing? How do we use it? We take 2,000 lead code examples. So this is a competition, about coding competition. The input data are correct, exercise objective, good code, and what is the optimal code to do it? We apply LibCST to parse all the code. We find some code that was, as a part of the solution of the competition, that is not even syntactical, and actually some JavaScript code in the middle. We remove that. We parse it with OpenBugger, inject bugs, and create 20,000 couples of bug and debugged code, and actually debugging trace. We give this as input to GPT, and use it to create 20,000 example of debugging operation. So this was the code that actually has some simple bugs that change the names of things. And this is what GPT comes up from the bugged code and the original code as a beginner question. And this is the answer that, as you can see, is using the debugging trace from that I showed before as a input, as grounding data for the generation of the answer. So GPT does not have the possibility to come up by itself with the coding solution. It already has the solution, so it's only giving natural language translation of the code that is already there. So we do not have to hope that GPT creates good data. We have by default data. Of course, sometimes it still makes it up, so we parse the output and check that the syntax tree of the output code is actually the syntax tree of the code that we generated. So just to go back, hopefully I'm kind of proud that I made it on time. The language model requires a lot of data. Good data is difficult to generate. We all would pay not to stay there and reply to someone else how to do those things. So that's what we did a bunch of years ago in the Stack Overflow era. And hopefully I can persuade you that this is a good idea to generate bugs. The bigger limit of this approach is, of course, is that you need to come up with the bugs and implement them. And I'm very good because that's what I do 99% of the time while I code, but there are some people that maybe here are too good to come up with that writing code to come up with, to realize how normal persons may bug the code. So just to finish, HK3 Lab, we are a research lab here of Reto. We're actually fully remote. We are funded for a bunch of years from Horizon 2020, and we are hiring on metabolic time series forecasting and gigapixel computer vision. That is computer vision over gigabyte-sized images that, of course, have a lot of compute problems. Other hat, new open source community about AI and machine learning, kind of a lot in the meme direction, and that I'm coming up with. The website is not really up. The GitHub is up with a lot of private code full of OpenAI keys forgotten into there. And if you guys are interested, please contact me. If you are searching for some machine learning project, we require skills at every level of the Python stack. We have 3 big projects. One is Baby Dragon, which is a chatbot, long-term memory and chatbot vector index package, something similar to LangChain, but more on the scientific stack. We have InfiniPy, which is Pygame engine, which can be played by GPT. So GPT reads the source code and acts, and actually GPT can write actions as code. So the idea is that it's a video game where everything can happen because you can modify the source code of the video game through happening. We only have demos, but if you are interested in this, come please help. And then, so finally, the latest project, which is kind of crazy, we are starting to digitalize all of the Akkadian and Sumerian tablets that we can find, because it turns out that GPT can translate a bit of Sumerian, so we want to actually train it on that. And yeah, this is a demo of what Baby Dragon does, which is like a chatbot package that has access to your Vent environment and automatically use LibCST to parse all of your code base, and then you can use it to ask questions. So anything that is in your computer can be indexed and used to search. Now it uses GPT as a backend, but it can also use open source language models. And I'm done.
Thank you very much for the talk. There's a question on Slido. Is the aim of the model always to correct the buggy code, or also just to spot the bug? If so, how do you ensure that the correct code is feasible to infer?
Okay, so the second part is easy to reply, the first one not. So for this project, yes, the objective is creating a debugging sets, but it's actually one could use the same sort of approach not for debugging. As an example, I could minify the code through syntax tree operation, which is kind of simple here because it means removing all of the new lines and all of the stuff. And then I could have a task which is not about code debugging, but about code minification. Instead, how do I know that the code can be debugged? Because we start from debugged code. We start from working code, invert it, and only use bugs that we know we can invert. So if there are a lot of exceptions for the syntax tree operation, like sometimes you put a new node and you end up removing something, or like inverting it, you get an isomorph tree that is not exactly the same. We discard those situations. Thankfully, like we are in a situation where we can generate much more data than we are actually able to analyze. So we can be a bit have some false positive and then analyze, remove the false positive, and only be sure to use things that we can invert, and we have full control into.
Okay, thank you. Do we have any other question in the room? Because we have some time. So if you want. No.
Just a comment. So the same approach could be also used for the language identification in general.
For, you mean,
yeah, so
like programming language or human language?
Also programming languages and probably also the spoken languages too.
Yeah, so the idea here actually comes from some ideas on using this translation approach. Like it actually comes from English to German translation and so on. So it's like a lot of time people in translation or like people that work in natural language exploit translation. So they translate something and then they do some operation after translating it, then they map it back and they want to check that the operation is consistent. And this typically you only have data in one language, so you can, and this also happens for styles transfer in image generation with cycle GANs, where you have two data sets and you want to have a model that maps from one to the other, but also invert it back. And here I realized that I was guaranteed to be able to invert back, so I kind of went in that direction.
So theoretically, from one language we can translate to another one, like from a Python to...
Okay, I have a collaborator that helps me, that helped me on this project. My biggest social challenge was stopping him from trying to translate Python to Rust like this. And I've seen there already some people twitching. Yes, but it is difficult. Like, I think it would be more like from some specific operation. You want to do like, I take all the for loops and it's a bit of, this, it requires really knowing the language to do it. It's above my pay level.
Hi, nice talk. Thank you. First question is, when is this going to be released?
I have to sleep, remove the OpenAI keys from it, and check that there were no, and I have to check whether under the PIP package, do you know if it is open again? Like they closed the registration to PIP a few days ago. So maybe I will release it on the test PIP. I mean, I will open this, I open source the code in a few days, but I'm not sure I can do the pip install because I didn't have, I tried the other day to register and it was blocked for some attack.
And the second question is there a size limit to how much code you can put into this?
Yes. So the size limit is like the wrong question at 2 seconds from the end because I can really go for 6 months into it. So that's the biggest limit. And I think also the biggest opportunity for good mathematical thinking in language models, that is this information bottleneck. We only have access to a limited prompt, and we have to decide what to put in it. Actually, that's why the minification part, because as I was saying, we have some problem with pandas that has 14,000 tokens classes, and we can't embed them and use and search on it. But yeah, there is a limit, and the limit is 1 page, and 150 lines of code, 200 lines of code. More than that, I wouldn't trust it.
Thank you very much for the talk.